cosmos. When we say that word, we usually picture an endless black abyss, cold, merciless, and lethal. Across its infinite expanses are scattered myriads of stars, from faint red dwarfs barely glowing in the darkness to blue giants that incinerate everything nearby. And this picture is completely true. But hidden inside that abyss are true wonders. Worlds where it rains molten glass, oceans hundreds of kilometers deep where water turns into exotic ice heavier than the liquid itself. Planets whose surface temperatures exceed that of the sun itself. And lonely wanderers, rogue planets that have raced through the darkness for billions of years, forever cut off from the warmth of a parent star. Their numbers are so vast, it is almost impossible to count them exactly. Yet every single exoplanet is unique in its own way, and their diversity is absolutely breathtaking. Although humanity cannot yet leave our own solar system, we can still embark on an unforgettable journey to the most remarkable worlds humanity has already discovered. Our adventure begins near the Automated Orbital Observatory, TESS, which has let us peer deeper into the mysterious cosmic void than ever before. With its help, we will visit the dim red dwarf TOI 700 and its potentially life-friendly planets. Then we will travel to the star T-Garden, home to the planet most like Earth ever found. After that, we will dive into the strange realm of Gliese 1214b, one of the rarest ocean worlds in the galaxy. Our path will then take us to the most hidden and enigmatic objects in space, rogue planets, stripped of any parent star. For billions of years, they have drifted alone through the depths, evading our gaze. And finally, we will confront an entire gallery of truly terrifying cosmic bodies. Extreme temperatures, deadly radiation, and hostile environments make these planets some of the most dangerous places imaginable. Get ready. We are beginning. Even at the end of the 1980s, we knew of exoplanets only from vague guesses. In the decades since, their numbers have grown many times over. As of January 2021, more than 4,000 planets belonging to other star systems had already been discovered, with several thousand additional candidates still waiting for final confirmation by ground-based observatories. The total number of planets in our galaxy is estimated to exceed 1 trillion. Between 5 and 20% of them have sizes and compositions close to Earth's. Not all lie in the habitable zone, yet scientists estimate that the Milky Way contains at least 300 million potentially habitable worlds. Conditions on these exoplanets are extremely diverse. There are gas giants many times the size of Jupiter, and small rocky bodies comparable in size to Earth. Some are scorched and covered in oceans of molten lava. Others are forever locked beneath ice shells. There are ocean planets with no solid surface whatsoever, and worlds where it rains sulfuric acid or snows diamonds. Directly spotting these distant worlds is almost impossible. That is why the National Aeronautics and Space Administration launched the Kepler Space Telescope in 2009, the first instrument specially designed to hunt for planets beyond our solar system. Its cameras had 42 sensors with a combined resolution of 96 megapixels and surveyed roughly a quarter of the sky. Combined with its 1.5-meter mirror, Kepler could peer up to 3,000 light years from Earth. In 3.5 years of active operation, it discovered more than 3,500 exoplanet candidates, over 2,000 of which have been confirmed, including the smallest known at the time, Kepler 37b, with a diameter of just 0.37 Earth diameters. The telescope used the transit method. When a planet passes in front of its star, the star's brightness dims slightly. The size of the dip depends directly on the relative sizes of the star and planet. The method demands extraordinary precision. Changes in brightness are often only fractions of a percent. Unfortunately, Kepler suffered serious failures in 2013 and finally ceased operations in 2018. Its successor, TESS, was launched by the National Aeronautics and Space Administration on April 18, 2018. Its primary mission is to find rocky exoplanets around the brightest stars within 200 light years. Equipped with 4 refractors, each with a 24 by 24 degree field of view and 10 centimeter apertures, and flying on a special orbit, TESS can observe both the northern and southern skies. During its primary mission, it identified more than 2,000 candidates, at least 66 of which have been confirmed. It has also captured supernovae, exocomets, and images of small bodies in our own solar system. It is TESS that has opened the door to the extraordinary worlds we are about to visit. But what if one of these worlds could actually support life? Our first stop is the dim red dwarf TOI 700, located just over 100 light years from the Sun. This small, cool star has a surface temperature half that of the Sun, and its mass and radius are only 40% of our stars. One of its most remarkable features is its extreme stability. Not a single flare has been recorded in all our observations. That kind of calm is rare and incredibly important for any chance of life. The system contains at least 3 planets. The innermost, TOI 700b, is Earth-sized, with a mass of about 1.7 Earth masses, and a radius differing from Earth's by only a couple of percent. Unfortunately, it orbits just 0.1 astronomical units from the star. Its year lasts only 10 days. It is almost certainly tidally locked, always showing one face to its star, and is therefore likely extremely hot. The second planet, TOI 700c, is a mini Neptune with a mass between 5 and 10 Earth masses and a radius 2 to 3 times Earth's. Its orbital period is 16 days, placing it just inside the inner edge of the habitable zone. But the third planet, TOI 700d, is the real jewel. Its year lasts 37.4 days, and its orbit lies along the inner edge of the habitable zone. Its mass is estimated between 1 and 2 Earth masses. Its radius is 20 to 30% larger than Earth's. The energy it receives from its star is 86% of what Earth receives from the Sun. If it possesses an Earth-like atmosphere, its equilibrium surface temperature would be minus 4.3 degrees Celsius. However, a greenhouse effect and other atmospheric features could shift that number significantly in either direction. The orbit has a modest eccentricity, so at times the planet ventures slightly closer to the star, but its short year means any uncomfortable periods would be brief. If life exists on TOI 700d, its inhabitants might endure harsh intervals in hibernation, adapt, or migrate. Spectral data are still limited, but they do not rule out the presence of liquid water. The planet is probably tidally locked. A thick atmosphere could moderate temperature differences between day and night sides, though it would also generate ferocious hurricane-force winds. TESS has completed its primary mission, but its resources are far from exhausted. It continues to observe, including the challenging plane of the Milky Way. Who knows what other astonishing worlds await discovery? But this is only the beginning of our journey. Now we travel even closer to home, just 12 light years away, to a tiny red dwarf called Teegarden. Orbiting this star is Teegarden b, the planet that currently holds the highest Earth similarity index ever measured, 0.95. The star itself is 1,370 times dimmer than the Sun, with a mass of roughly 99% solar and a radius slightly larger than Jupiter's. Its surface temperature is only 2,900 kelvins. Its habitable zone is narrow and lies very close to the star. Teegarden b's mass is just 5% greater than Earth's. Its radius differs by mere fractions of a percent. Surface gravity is almost identical to ours. Its internal structure is likely Earth-like, a massive metallic core, thick silicate mantle, and thin crust. The planet orbits at approximately 0.00 something astronomical units from its star and completes a revolution in just under 5 days. It receives 15% more radiation than Earth. Its calculated average surface temperature is about plus 28 degrees Celsius, 14 degrees warmer than Earth. Liquid water oceans are entirely plausible. Of course, there are challenges. Being so close to a red dwarf, the planet is almost certainly tidally locked, creating extreme temperature contrasts between the day side and night side. Red dwarfs are also prone to sudden flares that can increase brightness by up to 30%. Yet life is remarkably resilient. An ocean could shield against radiation and moderate temperature swings. In its warm, energy-rich, mineral-rich depths, primitive organisms might already be stirring. Just 12 light years away, a world that could be almost like our own. The thought is breathtaking. But not every promising world looks like Earth. Some are completely different. Welcome to the realm of ocean planets, worlds where there is no land at all, just one endless, crushing ocean, hundreds of kilometers deep. The theoretical foundation for planets completely covered by water dates back to the 1970s, when scientists proved that radioactive decay in planetary interiors and tidal forces could melt ice and create vast oceans. True ocean planets, however, are different. Here, the ocean is not hidden under ice. Its depth exceeds hundreds of kilometers. Theoretical calculations by French astrophysicists in 2004 showed that if a forming planet has a mass between 2 and 8 Earth masses, it will consist of roughly equal parts ice and rock. Far from its star, it becomes an ice giant. Inside the habitable zone, its outer layers melt, covering the surface in an endless ocean. A striking example is Gliese 1214b, 42 light years away. Its host star is a typical red dwarf, 300 times dimmer than the Sun. The planet was discovered in 2009. Its diameter is 2.5 times Earth's. Its mass is 6.5 times greater. Its density is very low, about 1,870 kilograms per cubic meter, indicating that 3/4 of its mass is water and water ice, with only 1/4 rock. The planet orbits extremely close to its star, just 0.014 astronomical units, completing a revolution in roughly 36 hours. Its orbit has noticeable eccentricity. Surface temperatures range from +120 to +280 degrees Celsius, depending on albedo. The atmosphere is a colossal steam boiler. Pressure in the lower layers is dozens of times higher than Earth's. At a depth of about 100 kilometers, pressure transforms water into exotic ice heavier than the liquid. This ice layer may be more than 5,000 kilometers thick. Below it lies a core of rock and metal. Spectroscopic studies of the atmosphere have so far produced contradictory results. A dense upper atmosphere may be hiding the true composition. In any case, life on such an ocean planet is extremely unlikely. There are simply too few essential trace elements, even accounting for occasional meteorites. The National Aeronautics and Space Administration modeling suggests billions of such worlds may exist in our galaxy, both cold ones with buried oceans and warm ones like Gliese 1214b. After all, water is one of the most common complex molecules in the universe, and nature loves to use it in spectacular ways. Now imagine diving into that endless sea, deeper than any human could ever go, into a realm no spaceship could survive. But what if a planet has no star at all? These are the rogue planets, orphan worlds drifting alone through the freezing void of interstellar space. No sunlight, no warmth, just endless night. The closest confirmed rogue to Earth is WISE 0855-0714, only 7.27 light-years away. Discovered in 2014, its temperature ranges from -48 to -13 degrees Celsius. It resembles a cooled gas giant with an atmosphere containing clouds of tiny ice particles. Beneath thick ice clouds in a dense atmosphere, pockets of liquid water might still exist, kept warm by internal radioactive heat. Some rogue planets were once gas giants violently ejected from their birth systems. Others are rocky worlds flung out during cosmic catastrophes. The Milky Way may contain up to 100 billion of them. In 2020, another rogue planet with roughly Earth mass was discovered via microlensing. It is likely a rocky world ejected during a cosmic catastrophe. If it retains a thick atmosphere or ice layer and enough internal heat from radioactive decay, a liquid ocean could persist beneath the surface. Primitive anaerobic life is theoretically possible, though detecting its traces would be incredibly difficult. A new project called Cleopatra is now in development. It will search for rogue planets using microlensing with a dedicated interplanetary spacecraft and powerful artificial intelligence. Launch is planned for 2025 alongside a Mars mission. What fate awaits these worlds? Most will drift alone through darkness for billions of years, slowly cooling until they are swallowed by black holes or destroyed in cosmic catastrophes, their secrets forever unrevealed. But even these ghostly worlds are not the most terrifying places we will visit. Now we enter the true nightmares of the galaxy, places where simply getting close could destroy you. In 2020, the National Aeronautics and Space Administration compiled a list of the most frightening worlds, and we will visit the most unimaginable among them. TRES 2b is the darkest planet ever found. It absorbs more than 99% of incoming light. Its atmosphere is heated to 1,000 degrees Celsius, and the planet glows faintly red, like dying embers. 55 Cancri E is a literal hell. With roughly 8 Earth masses, it is tidally locked. Dayside temperatures reach 2,400 degrees Celsius. Nightside temperatures are 1,300 degrees. Its interior contains thick layers of graphite and diamond. Poltergeist, PSR 1257 plus 12C, orbits a pulsar. Located just 0.36 astronomical units from the neutron star, it is bathed in lethal radiation that would destroy any spacecraft. Kepler 70b is among the hottest. Its surface temperature exceeds that of the Sun. Its orbital period is only 5.76 hours. It may once have been part of the star itself. WASP-12b is being slowly devoured by its parent star. Surface temperature is 2,200 degrees Celsius. In about 10 million years, the planet will likely be completely destroyed. HD 189733b is a blue gas giant where winds blow at 8,000 kilometers per hour and it rains molten glass. Its atmosphere contains haze of silicates, iron, and aluminum oxide, along with water vapor, methane, and carbon monoxide. K2141b is a rocky planet with a permanent lava ocean on its dayside at 3,000 degrees Celsius. Supersonic winds howl across the terminator, carrying molten metal that rains down as fiery rivers on the freezing night side. And KELT9b is one of the hottest planets known, 4,300 degrees Celsius. Its atmosphere is literally evaporating into space, boiled away by its star. The gas envelope contains iron and titanium vapors. These are only the tip of the iceberg. Some planets orbit so close to their stars that they are slowly evaporating. Others circle pulsars and are blasted by lethal radiation that would shred any spacecraft in seconds. These worlds are not just hostile. They are vivid warnings of how rare and fragile the gentle conditions on Earth really are. We have journeyed across only the tiniest fraction of the infinite variety of exoplanets in our galaxy. Hundreds of billions of other worlds still remain hidden from our eyes. Yet with every new discovery, we understand more. What seemed impossible yesterday may become ordinary tomorrow. And maybe, somewhere out there right now, on one of these countless worlds, someone or something is looking up at the sky, wondering if we exist. Or perhaps we will be the ones who finally reach out and make first contact. Thank you for joining this extraordinary journey with us. If you felt even a fraction of the wonder we tried to share, hit that like button, subscribe, and turn on notifications. The universe has so much more to show us. Until next time, keep looking up.